to solve a quadratic equation. So let's solve this equation. Now, how do you solve it? We solve it by factorizing. So how do you factorize this? You're going to multiply 3 by 2, 3 by negative 2. Okay, so you go 3 times negative 2 equal to negative 6, and find two numbers which multiply to get negative 6, but add to get negative 5. So which two numbers will it be? Minus 6 and 1? No, not minus 6 and 1. Minus 6. Oh, you have to add. Yeah, you're right. Yeah, minus 6 and 1. You're right. Minus 6 and 1. And then you're going to split the negative 5 into two parts. Negative 6x and x. And then you group in pairs, right? Which is quite a lengthy process. So we end up getting 3x. 3x bracket x minus 2. And then plus 1 x minus 2. Yes? And then you end up getting, now can you see the x minus 2 is common? And then you factorize that out. So you end up getting x minus 2 in front. And then you get this, which is 3x plus 1 equal to 0. And the multi-factor law says that either x minus 2 is 0 or 3x plus 1 is 0. Like that, and you get x equal to 2. And x equal to negative a third. You probably did it in a different way, but you'll get the same answer at the end. Okay, alright, write it down. Alright, so you times 3 by negative 2, get negative 6. Find two numbers which multiply to get negative 6, add to get negative 5. And then numbers are negative 6 and 1. Split the negative 5 into negative 6x and positive 1x. And factorize in pairs. Write it down. Okay, continue. Alright, hopefully all done. Alright, so what do we do with this? These are called the roots of the equation. So the roots are 2 and negative a third. Right? These are the roots. And the next question is, what will happen when we add the two roots together? 2 plus negative a third. What does that give you? Using your calculator or do it by hand, you will get 5 over 3. Okay? And I also want you to do product of the roots, which you have to multiply the two roots together. You get negative 2 over 3. There's some patterns involved. So what's the pattern there? If you look at the investigation, you will see that if this is your A, that's your B, that's your C, you will notice that the product of the roots is exactly C over A, isn't it? Right? Negative 2 over 3, so you get C over A. That's your product. And you will see that the sum of the roots is the negative B over A. Right? See the negative B, the 5, become positive 5 over 3. So these are the formulas. So you notice that the product equal to C over A, and then the sum equal to minus B over A. And these two formula are on the reference sheet. On reference sheet. On reference sheet. Like that, yep. Okay. Alright, so we can actually prove this, and the proof is not examinable, but it's actually quite interesting. Alright, there it is. These are the formulas, so you can highlight it. Let me get the highlighter. So that's on the reference sheet. So, and then change the pen on reference sheet. Reference sheet. Okay, any question? Pretty straightforward. And let's see why this is the case. Is it just a fluke? Does it always work? So we can actually prove it. Okay, let's prove this. And to prove this, so we'll call the two roots alpha. One of the roots alpha. This is beta. Okay, it doesn't matter. So one is the plus, one is the minus. Two roots. We're going to add them together. See if we get negative b over a. Okay, so that's come from the quadratic formula. So let's add them. So we go alpha plus beta equal minus b plus root b squared minus 4ac, thank you, over 2a plus minus b minus root b squared minus 4ac over 2a. We're adding the two roots together. See if we get negative b over a. Okay, so we can actually prove that it works. Continuing on, due to the fact that they have the same denominator, we can put them on the common denominator. Let's put them on a common denominator. Equal, draw a long line to a, and we get minus b plus root b squared minus 4ac plus negative b minus root b squared minus 4ac. Yeah? Now, is there any like terms? Which two are like terms? Yeah. Yeah, see, can you see that thing gets cancelled? You get cancelled, and then if we add the remaining term, what's negative b plus negative b? Negative what? Negative 2b. Very good. Over 2a. Right? So what happened to the 2? It gets cancelled, and not surprisingly, we do get negative b over a, right? We get this. So it's quite cool. The sum of the roots is quite simple. It's just negative b over a. All right? We did the sum. How about we do the product? I think product is a little bit harder because you have to multiply two things, and that involves a little bit more algebra. Okay, hopefully you're ready to do that. Let's do the product. So let's do the product. Alpha times beta. Let's write it here. So I draw a line in the middle. Product. Let's do product. So alpha times beta equal to minus b plus root b squared minus 4ac over 2a multiplied by minus b minus root b squared minus 4ac over 2a. Now, product is a bit harder. We have to multiply. You do need it today. Okay, so, okay, now to times them, the denominator is easy, right? Because 2a times 2a is 4a squared, right? So you just get 4a squared. But the top is a bit harder. But let's see if you can recognize it. It's a good algebraic exercise. See if you can recognize it. If you don't recognize, you just have to do it the long way, but I prefer you to recognize it and be able to work out very quickly. You can identify what sort of product it is. Of course, it will be one of these that you've learned before. Difference of two squares. Yes. Can you see they're the same? The only difference is one has a plus, one has a minus. Yeah? So that's a difference of two squares. So you go minus b bracket square minus bracket square root of b squared minus 4ac. Difference of two squares over 4a squared. So again, it will cancel out nicely. See if we get c over a at the end. See, that's something that's very nice about maths. You start off with something very complicated, but as you simplify things, you get something very simple. Okay, see if we can simplify it. Okay, so we continue. So we get negative b squared, which is b squared. And when you square the square root, it gets cancelled. But make sure you put a bracket there. B squared minus 4ac, 4a squared, right? And then you got to be careful is that the minus, this minus there, we have to expand it. which you end up getting negative b squared plus 4ac, right? Over 4a squared, like that. And then you notice that the b squared get cancelled, and you end up with 4ac, and that will cancel with the 4a squared at the bottom, and you will see that the minus, the 4 get cancelled, the a get cancelled, you end up with c of a. So it's very cool, isn't it? It's like having a storm, and then after that it becomes sunny. Alright? Yeah, it's like you start off very complicated, get it very messy, and then at the end you come out very nice. Okay? Alright, good. So we see this proof. Again, the proof is not examinable. The sum is negative b over a. The product is c over a. Okay, memorize these two formula. We're going to use it to... Actually, before I start, I'm going to link it with the other topic. Remember, you have axis of symmetry. How do I get axis of symmetry? And the question is why? Well, we see that axis symmetry is the two x-intercept, the average, right? And the average of two x-intercept is exactly the average of the two roots. And if I do that, that's equal to half times b over a. That's where they get the formula from, b over 2a, right? Because it's the average of the parabola. So if I go like this, that's your parabola, right? That's your axis of symmetry. It's the halfway between the two roots, alpha and beta. Does that make sense? Oh, yes, sorry, negative. Yeah, you're right. Thank you. All right, does that make sense? It's all connected. So we're now going to move on to the next page. When you're ready, we're going to apply these formulas. Right, you might miss the important part, but doesn't matter. Let's move on. Okay, you probably have learned that already. Okay, let's move on to the next page. All right, let's go to the next page. We'll do some calculation questions. That's in the textbook. Okay, let's start with this. Very easy. First step. This is the quadratic equation. You do not need to solve to find the sum. So you just have to write down what A is, what B is, what C is, right? So write down A equal to 2, B equal to 3, and C equal to 4. Does that make sense? And then what you do is you're going to do alpha plus beta equal to minus B over A. Just use the formula. And B is 3 over A is 2. That's it. You do not need to find the root. You just have to use the formula. All right? Okay. How about the next one? Alpha beta. Use the formula. Alpha beta is C over A. C is 4 over 2 is 2. Very easy. Yep. Okay. Now the next one is not on the formula sheet, but you can actually express it in terms of sum and product. So what you need to do is to make them the same denominator. Alpha, alpha, beta, beta. Now they have the same denominator, and you worked out to be beta plus alpha over alpha beta. Okay? And once you do this critical step, you will know the numerator is this thing, minus 3 over 2. So you write minus 3 over 2 divided by the product, which is 2, which you found before. Does that make sense? And if you simplify it, you should get negative. Now, how do I simplify a fraction over a number? You divide by the denominator, which is same as negative 3 over 2, times by half. So the answer is negative 3 over 4, or you can just do it on a calculator. Okay? And on the calculator, make sure you type in. A lot of people late today. Okay, anyway, sit down. So you can just go like this, fraction, and then you have to go like this, put fraction on the top, negative 3 over 2. And then over 2, it could give you negative 3 over 4. Okay? All right, let's continue. Okay, all right, there's still important questions. How about the next one? What should we do? Expand it. Let's see what we get. Alpha times beta. We're on page 21. Okay, thank you. All right. So alpha beta, 3 alpha plus 3 beta plus 9. Okay. And then what we do is alpha beta plus, you factorize the 3 out, plus 9. Okay. Now you see something. You can now mix and match. So alpha beta is 2. And then the alpha plus beta is negative 3 over 2 as we found. So the key to this problem is to express using product and sum of the original formula. Okay? Once you got the alpha beta and alpha plus beta, you're ready to substitute. And then just use your calculator. I'm going to use a calculator for this one. Okay, so you go 2 plus 3 times, I'll do decimal because it's easier to type, plus 9 equals 6.5. 6.5. Done. Okay. Alright, that's good. We did that. Okay, what else do we have to do? Next one is a little bit tricky. Who remember from the extension what to do? There's a formula. Yes? Yes, you just memorize that formula. Very nice. Very good. So memorize this. Now, how does Jacob get this formula? You just have to expand this. So if you expand the perfect square, let's do it here. You get alpha squared plus 2 alpha beta plus beta square. You will notice that the 2 alpha beta get cancelled. And you end up getting alpha squared plus beta squared. Right? So you have to memorize this formula. This is something that they ask a lot, and it's not on the reference sheet. So I suggest you to memorize it. Okay? So I'm going to go like this. Okay, let's try to do that. So the sum alpha plus beta is, what's alpha per? Negative 3 over 2 square minus 2 times the product, 2. Yep. Using a calculator, you get 9 over 4 minus 4. That will be too hard for me. So you just go 9 over 4 divided by 9 divided by 4 minus 4. You get this, okay, negative 7 on 4. Okay, negative 7 over 4. Any question? Pretty good? What else I'm going to say? Okay, good. I'm going to show you another way to do that. Not that you have to use this, but it's quite interesting. I'm going to give you method 2. Maybe you haven't seen that before. Method 2. Alright, method 2 goes like this. Maybe I'll write it in black. Okay. Method 2 goes like this. So the equation was 2x squared plus 3x plus 4 equal to 0. Right? So what you do is you substitute alpha in because alpha is a root. You may not like method 2 because it looks a bit more intense. And then you can substitute beta. Like that. And then we're going to add the 2 equations. Plus. So you get 2 bracket alpha squared plus beta squared plus 3 alpha plus beta plus 8. I think this is longer. And then what you do is the alpha plus beta is minus b on a, which is minus 3 over 2. And you can just work it out. So you end up getting 2 alpha squared plus beta squared times plus by 3 times this plus 8. Use your calculator. 3 lots of negative 1.5 plus 8. You get 3.5. So you get equal to 0. So 3.5 plus this. I think this is too long. You may not like it. And then you get alpha squared plus beta squared is this. I think that's far too long, which is equal to negative 7 on 2. Okay, but that's not relevant. Okay. So you add the 2 equations and you get this the subject. Right? 3 times negative 3 over 2 and you add them, you get 3.5. Move it along, you get this. Okay? Oh, sorry, negative 7 on 4. Oops, sorry. I made another mistake. Okay, good. Alright, just ignore this. I think it's a bit long. Alright, after this, we'll do something easier. I want you to solve this equation. Have a try, solve it. It's very easy. Ask a student in a minute time. Go. Well, I think that's not a good way, so I'm going to rub it off. Big mistake. Oops, sorry. Just get rid of it. It's not a good way. Just use the first method. You get confused, use that. That's very easy. Alright, thank you. Alright, solve this one, example 25. Alright, example 25. Okay, Anthony, how do you solve it? Go. Alright, good. And Lisa, what's x equal to? One and two, very good. Alright, done, easy. Now, what's the purpose of this? Well, the purpose is not to solve the equation, it's actually answer the next question. How do I get the equation with given the answers? Say the answer was x equal to 1 and 2. What's the equation? Well, we've already done it above, right? We've got this thing, right? So we just have to work backwards. So to get the equation, you just have to rewind. So if I rewind, what's the step before this? I would have wrote x minus 1 equal to 0, x minus 2 is 0, right? And what's the other step? I combine them. And if you expand it, you get x squared minus 3x plus 2. So that's the equation. So in this case, we're going to reverse. I want to find the equation if I give you the solution. Basically, give me the answer, give me the question. Before I give you the question, give me the answer, we'll do the reverse. Alright, how about the next one? Okay, do the same thing. The answer was -2 and 5. Do the reverse and tell me what the answer is. Have a try. And then we'll see if we can find a quicker method. Alright, we've got 3 more pages to go through. 2 more after this. Okay, what's the answer? So you would have got x plus 2 equal to 0, or x minus 5 is 0. And then you multiply the 2 factors together. And if you expand it, you get x squared minus 5x plus 2x minus 10 is 0. Yes? And you get collect like terms. And the question is there a faster way? Who can see a faster way? Well, the faster way is this. Notice the 3 is the sum of the roots, right? 1 plus 2 is 3. That's 1 plus 2. And what's the other one? 1 times 2. Does it work with the other one? The 3, -2 plus 5. The -10 is -2 times 5. Right? So we have a faster way. So going back to this question, in general, if you want to find the equation, you just use this formula. The coefficient of x is the sum, negative of the sum, and the constant term is the product. So basically, in words, we go like this. It's x squared minus sum x plus product equal to 0. Right? So now I could do this quickly without doing all the work. So to find the equation, you go x squared minus the sum plus the product equal to 0. So you just have to insert. Now you can make up equation for other year 10 to do. You just have to think of 2 numbers, add it here, and then times it here. And there's your question for them to try. So what do you get? You'll get x squared minus 3x minus 10. That's it. And if you try to factorize it, you'll be guaranteed with these 2 answers. Okay? Okay, try the next one. So it gets a bit harder where a surt's involved. But it's not going to get more difficult, isn't it? You do the same thing. Have a try. Try to find the equation with these 2 roots. And your answer doesn't have surts in it. I'm going to prepare you. So something x plus something equal to 0. Okay, have a try. Right? You don't really need a calculator, but if you know the algebra. Okay, so what do we have? We're going to add the two roots together, 1 plus root 3 plus 1 minus root 3. Yes? And then the product is 1 plus root 3. So basically, this is your alpha, this is your beta, right? And you're going to times them. So, right, alpha, beta, times them, 1 minus root 3. Okay? And you'll see that root 3 and negative root 3 gets cancelled, and you end up with 2. So you get x squared minus 2x, right? Now, how about the other one? Do you recognize what this is? What's that? Excellent. Difference of 2 squared. So you don't really need a calculator. You go 1 squared minus root 3 squared. And 1 minus 3 is negative 2. Okay? So that's it. That equation have 2 roots. Yeah. Okay. Any questions? So it's pretty easy. Okay. Done. So 1 minus 3, right? Root 3 squared is 3. 1 minus 3 is negative 2. Maybe I'll do it here. 1 minus 3, which is negative 2. Yeah, here, alpha, beta, product. Alpha, beta, times. And that's sum, alpha plus beta. Alright, good. Let's move on. Thank you. Now we'll do some harder question. That's the hardest question in the exercise. Pay full attention. Okay, this one. Now we're going to do something like we did before with the discriminant, where you have to find k. And they give you some clue that the sum of the roots is 5. Well, let's write it down. For alpha plus beta is 5. Now, how do we use it to find k? Because alpha plus beta is minus b on a, equal to 5. And what's b? b is negative k plus 2 over 1 equal to 5, right? And what happened to the double negative? Become positive. And anything over 1 is itself. So the k is 3. Does that make sense? Yep. Yes, I'm just showing working how they got it. So you can just go straight to here. You don't have to do these 2 steps. Yep, you're right. All right, next one. Alpha beta is 20, so you go C over A is 20. C is 4k over 1. Sorry. All right, continuing on, you get 20. So 4k equal to 20. K is 5. So it's pretty easy, isn't it? All right. I think the next one's a little bit harder. Oh no, next one's still not hard. Okay. What's this? So they give you this, then that to find k. Let's look at the next one. Find the value of m, where the 1, 0, now another word for 0 is root. 1, 0, 1 root is 1. So when that happens, you do not do alpha plus beta. What you do is you just substitute x equal to 1, because they give you an answer into the equation. So you go 1 squared minus m times 1 plus 2 is 0, and work out what m is. So remember, when they give you an answer, substitute to find m. So what do you get? You get 1 plus 2 is 3 minus m is 0, m is 3. Yeah. Now you don't have to do this. We can test this out. We'll see if whether that works. So test. If m is 1, let's see what sort of equation you get. You get x squared minus 1x plus 2, right? Oh, actually 3, sorry. So you get m equal to 3, and you get minus 2 minus 1, right? So x equal to 1 and 2. Yes, indeed, one of the root is 1, right? Which is over here, right? Does that make sense? So when you put m equal to 3, you do have one root to be 1. The other root, it can be anything. All right. I've got 2 more to do. This one gets a bit harder. That's the hardest part, the next 2 pages. And you're going to get lots of questions in this in the examples, in the exercise, and then we're going to do the textbook work. Alright. Alright, all finished? Yeah? Next page. Again, we're going to find m. But this time the clue is even more vague. They don't give you the root, they don't give you the sum, they just say one solution is double the other solution. So what you do is, instead of saying the roots are alpha and beta, you will not do beta because you say twice the other, you get alpha and 2 alpha. Reduce the number of polynomial you use. Okay? Alpha and 2 alpha. And then what you need to do is to do the sum of the roots. Let's do the sum. The sum is alpha plus 2 alpha. And what does that equal to? 3 alpha. And even though it's double the other, it's still equal to negative b over a. Yes? So you get 3 alpha equal negative bracket m plus 2 over 2. Right? And double minus is plus m plus 2 over 2. And then to find alpha, you divide by 3, m plus 2 over 6. Now, we cannot find m because we've got 2 polynomial. Let's call that equation 1. We're going to solve simultaneous equation. After we do the sum, we have to do the product. Let's do the product. And then we do alpha times 2 alpha equals to c over a. And 2 alpha squared equal to c, which is m over 2. Right? Okay, now what do we do like before? We're going to substitute. Okay, let's divide by 2 first. Okay, equation 2. And then the algebra can get long because now you have to solve them simultaneously. Now the question asks for m, right? So how do I find m? You have to eliminate alpha. How do I eliminate alpha? We have to combine them. Combine. Now how do we combine? So we substitute. Now see, alpha is this. So let's write alpha here. Alpha equal to m plus 2 over 6. Now replace the alpha by, we'll substitute that into the square. Yes, let's do that. So we're going to go m plus 2 over 6 squared equal to that. And you have to solve a quadratic. Alright, go. Alright, good. So we get the 2 equations, the sum and the product, and solve simultaneously. So what do we get? We get, we're going to expand, so we're using the perfect square formula, m squared plus 4m plus 4 over 36 equal to m over 4. And then what you do is multiply both sides by 36 to get rid of the denominator. And then you cross out the 36, cross out the 4 and the 36, you get 9. Yeah. And you get m squared plus 4m plus 4 equal to 9m. And to solve the quadratic, you move the term to the other side. You get m squared minus 5m. Because 4 minus 9 is negative 5. And you solve the quadratic. Yep. So what do you get? So you get m minus 1 and minus 4 equal to 0. So what's m equal to? 1 and 4. Make sense? Alright, I'll put it on a bigger page. There you go. So study the algebra very carefully. That's one example of a very difficult exam question. You have to do the sum, do the product, and then combine them, solve simultaneously, and you get a quadratic equation and you solve it. Okay? Alright, let me show why it is double. I'm going to show you now. That's why I've got the whole page. Okay, let's substitute m equal to 1, right? If I put m equal to 1, the equation becomes 2x squared minus 3x plus 1, right? And if you solve this equation, which I will do it very quickly, 2x minus 1, x minus 1. See the roots are double the other. Can you see the 1 is double the 2? That's alpha, that's 2 alpha, right? Yes? Or if you do m equal to 4, you get 2x squared, 2x squared plus minus 4, 4 plus 2 is 6x, plus 4, right? And what do you get? X squared minus 3x plus 2. And x minus 2, x minus 1. Again, you get one root double the other, right? So you get alpha and 2 alpha. Does that make sense? So when you found these m values, that make the equation one root double the other root. But you don't have to do this. This is not needed. I'm just showing you how it works. So Jack, does that answer your question? Why one root double the other? Remember, m is not the root. M is the value that make the equation one root double the other root. Yep, thank you. All right, 2 more questions, then we're done. Next page. Hopefully all okay. All right, so this is a hard question. So make sure you study that if you get that in the exam. Okay, next one. It says one root is opposite the other roots. What would you do? What does opposite means? If one root is alpha, the other root is negative alpha. And then we'll do the sum again. Let's do the sum. Sum of the roots equal to minus b over a. And what do? Sum is alpha plus negative alpha equal to minus b over a will be minus m plus 2 over 2. Now what happened to the double negative? It becomes plus. And what happened to the alpha and minus alpha? It becomes 0. And this is good news. I don't have to solve simultaneous equation because I could now work out what m is without working the other equation. So you end up getting m plus 2 equal to 0. M is negative 2. Done. We don't have to do anything else. Does that make sense? So if they cancel, then we don't have to do the second equation. We'll just work out m. Okay? So look out for something that's opposite to each other because summing them will give you an easy number. Okay? Now, what if I times them? If I times them, you get c over a. But it's not going to help you, right? You're going to get this, right? 2 per numeral. So I can't really use this. I just need this is enough. Okay? Alright. Now you may ask, what if I put negative 2 into the formula? Do you get one root to be the reciprocal of the other root? You do. So let's substitute m. So let's say m is negative 2. What do you get? 2x squared minus negative 2 plus 2x minus 2. And what do you get? You get 2x squared minus 2 is 0. X squared equal to 1. X is plus or minus 1. Yes, they are opposite of each other, right? That's alpha. That's negative alpha. Does that make sense? Alpha, negative alpha. Okay, good. Next one. One root reciprocal of the other. What would you do? Alpha and 1 over alpha. But this time, yep. Because 0x, 0. Negative 2 plus 2 is 0. Yeah, thank you. Alright, let's do reciprocal. Now reciprocal, I will just do the product straight away. Because when you do product of reciprocal, they cancel out. Right? So you do alpha times 1 on alpha equals to m over 2. And alpha times 1 over alpha is gone, right? You get 1. So what's m equal to? M equal to 2. And in fact, you don't do the sum. If I do the sum, it's going to be complicated, right? And that's going to be hard, right? They don't cancel each other out. So don't do sum. Just do product. Some of you can tell You can write both, and if that gives you the answer, don't bother using the other one. So just write both of them, see which one give you. But if both of them don't give you anything, you have to solve simultaneously. Yep. Okay, good. Again, let's substitute. So we're going to go m equal to 2. What does the equation become? 2x squared plus minus 2 plus 2 x plus 2. What does that give you? 2x squared minus 4x plus 2. And what do you get? You get x squared to be minus 2x plus 1. Oh, it's a perfect square. And is the reciprocal of the other? X minus 1. X minus 1 is 0. That's why it's called a double root for a reason. Because the 1 is the alpha. Oops. The 1 is the alpha. The 1 is also 1 over alpha, right? Just happens to be the same number. Okay. All right, all good. So today you do exercise. What exercise do we do? Exercise 9.5. A lot of questions. So you have to do, but you got the weekend to do it, okay? And then you got extra 8 to something, okay? I think it's cooler on Sunday. Yep. Thank you.